Hey guys, okay, here we go, part 10. We're on number 26, and this is just all the definitions for electrostatics. These terms, if they are on the exam, it will probably be matching. So just try and remember the specifics about what's the difference between an insulator and a conductor, what's polarization, and the difference between induction and then charging by conduction / contact and charging by friction. Okay, there was one little kind of adjustment I made to this part, and it was that I included charging by conduction / contact, and I put them into one because I don't know why, but I put it twice in your final exam or your study guide, and conduction and contact are the same thing. All right, so let's just start. I typed it all up because it'd just be easier that way for me to explain it. We have insulator. What's an insulator? An insulator is a type of material that will hinder the free flow of electrons from atom to atom, and molecule to molecule. So we have a whole list of what is a good insulator and what is a good conductor. And just thinking about what we did our demonstrations last week on our electrostatics lab, just consider, what's a good insulator? Is it the PVC pipe, or is it the cotton towel that was rubbed on that PVC pipe? Well, actually, the cotton towel is a conductor. It's a material that will permit electrons to flow freely from atom to atom, molecule to molecule. So all of those electrons that are on the atoms that make up that material are released, and the insulator then holds on to that extra charge, and that makes that insulator, the PVC pipe, a negative charge. And then we were able to move around the soda can, and we were able to make that matchstick move. So we were using that negative charged material to kind of attract, opposite charges. All right, so the next definition is polarization. And what's polarization? Polarization is just a process of separating opposite charges within an atom. I got this image off of physics classroom. And in fact, the remaining questions on our study guide after these ones, not the next two, but like the following pictures, those are all from physics classroom as well. If you go into the physics classroom and look up static electricity, there's a lot of great useful information on there for you guys. So this is just an example of polarization. Polarization is just the process of separating opposite charges within an object. And what you do is you take a neutral object, and this is a neutral object, the soda can, or this cola can they're calling it. And the only reason why it's resting on this styrofoam cup, in fact, this is a demonstration I did last year in my classroom. But since it's sitting on a neutral insulating stand, that means that it can't gain or lose electrons because that insulator is, acting as an insulator. So then the process of separating opposite charges within an object. So we have equal number of electrons and an equal number of protons right now in our soda can. So you just have to keep that in mind. But once you bring in this negatively charged object, right, this balloon in this person's hand, and it's negatively charged, which means it has more electrons, then what happens to the charge in the soda can is that they separate. And these electrons, and you can see the arrow acting this way to the right, these electrons in the soda can are repelled by this negatively charged balloon. So then what happens is that you have all the positive charges in the soda can coming towards that negatively charged item, that negatively charged balloon, because remember, they're attracted to each other, and they separate from the negatively charged electrons. So they go from one side to the other. We call it poles, one pole to the other pole. That's why you'll hear that more often when you go into biology and chemistry, that like water has different poles, a positively charged, or a partially positive pole and a partially negative charged pole, and that's just referring to the polarization that's occurring between hydrogen and oxygen atoms. Okay, So that's what polarization is. It's just the process of separating opposite charges within an object. What's really important is that you always start with a neutral object and then you bring in a charged object. Now, it can be a positively charged object or a negatively charged object. If this object here, if this balloon was positively charged, well, then all the negatives would be here and all the positives would be over here. Okay, that's just what would happen. Okay, so the next term is, charging by induction. Charging by induction is a method used to charge an object without actually touching the object to any other charged object. So induction, without coming into contact, and you're actually charging the object. All right, charging by conduction, conduction/contact. These two terms mean the same thing. Again, I had charging by contact written down here, but I erased it and I added it to this one. And I didn't get a chance to do that to your study guide, but I did do it here as I explain it. So charging by conduction, this is pretty easy. It's just a method that involves the contact of a charged object to a neutral object. So there you go. Okay, charging by friction. This one's also very easy to remember. It's just you're rubbing two atoms together. Now the thing is that these atoms that you're rubbing together are going to be opposite types of atoms or opposite types of material. One is going to be an insulator and one is going to be a conductor, because what you're trying to do is you're trying to charge those objects. And the only way you can do that is if you rub an insulator and a conductor. Now, this is kind of a general term because remember you have that list, that triboelectric list, right? You have things up here that are more like insulators, and you have things down here that are more conductors. Now, let's say you have an object down here that's like really, really a conductor, but then you have an object that's just kind of like maybe 2 steps above it. This is still a conductor, but this object is more like a conductor than this object would be. And so we could use these two objects. They just have to be on, different levels of that triboelectric effect guide or level. Can't even think of the term I'm trying to use. But just so you know. Okay? All right, so that's charging by friction. All right, let me go over now the other problems. So here we are on number 27. Upon entering the classroom, you observe 2 balloons suspended from the ceiling. So you kind of have this right here's your ceiling, and you have 2 balloons. Can I draw a balloon? I can, kind of. That's the string holding it. Anyways, okay, so you have 2 balloons, and they're suspended from the ceiling. And you notice that instead of hanging straight down, where there would be no gap here, they're actually repelling each other. Why? Well, consider the electrostatics and explain why this is occurring. Well, let's just say somebody came over here and produced a negative charge, or, well, actually, no, this is rubber, so it'd be negative. A negative charge on both of these. Since these both now have a negative charge, they're going to repel each other. Okay? If one of them was left neutral, right, and this one had been, causes or something happened to this one, probably charging by friction, gave this a negative charge, well, then these would no longer repel each other. They would attract each other. Right? And they would come together. All right, next problem. Number 28. How do conductors and insulators differ? Well, it's how freely the electrons flow. Now, I know that there's probably a much more technical way of saying this, but really, if you have a conductor, well, then your electrons are free to flow all over the place, and you will lose electrons, you will gain electrons easy, but insulators gain more then give up. They hold on to their electrons, okay? So electrons aren't so freely to move around. And this kind of takes us back to the polarization. Typically, when you have conductors where the electrons can flow really easy, you're going to have polarization occurring much easily than in conductors than you would have acting in insulators, because insulators hold on to those electrons and they can't really separate as easily as conductors can, because remember, polarization is the separation of those charges. All right, here is that picture, those pictures I was talking about and how they came from physics classroom. Definitely, if you guys are still slightly confused about what's going on after I explain it, check out the physics classroom, physicsclassroom.com. You go to the tutorial part. I think it's tutorial part, and then click on static electricity. All right, so one of these isolated charged spheres is copper and the other is rubber. So these are talking about insulators and conductors, okay? So copper is actually a really great conductor, and an insulator, rubber is an insulator. So the diagram below depicts the distribution of excess negative charge over the surface of two spheres. Label which is which and support your answer with an explanation. Okay, so this is all about polarization. Polarization. I'm sorry, I probably spelled that wrong. So if you guys remember, polarization is when you're able to get your charges to sort of go from one side to the other, and you're able to like kind of equally distribute all your charges. Well, rubber will not. Well, it's an insulator, so its electrons don't really move so freely around, versus a copper, which is more of a conductor, right? And it allows its electrons and everything to move around freely, and they will actually look more like this one because they are free to, go to all poles, all areas, compared to the insulator rubber conductor. Maybe I shouldn't have brought polarization into the mix right now because that might just be slightly confusing. So let's leave it more like the reason why this is happening is because an insulator will not allow its electrons to sort of freely move all around, right? Where a conductor, it allows the electrons to sort of go wherever they please, and they want to be balanced out, and so that's what they're doing there. All right, now this is polarization. Okay, charged rubber rods are placed near a neutral conductor, or a neutral conducting sphere. Remember, for polarization, you have one charged item, and that's usually the item that is coming in close to a neutral material, and we're talking about a neutral conductor right here. This rubber rod is in a couple of different, each diagram has a charge different on each of them, but it's causing a redistribution of charge on the spheres. Which of the diagrams below depict the proper distribution of charge on the spheres? List all that apply. Okay, so again, this came from physics classroom. This is just saying, now this is probably going to be a problem on the question, on the exam, so this is important. List all that apply. It's asking you to show the correct distribution of charges when polarization occurs. Remember, you have one charged item or material coming close to or in the vicinity of a neutrally charged object. The neutrally charged object is going to have the same number of electrons as it has protons, and that charged object, the rubber rod in this case, is going to have either a negatively charged or positively charged. And I just realized I had 14 minutes and 30 seconds, so I have to end now or else I can't post this. So you guys, on the next video, I will start off with number 30. All right, have a good day.